Hello everybody and welcome to the first lesson of this new amazing chapter, which is about strings. In this lesson, we are about to find out what strings are, how they are implemented, what operations are supported on them, and then we are going to find out more about mutable and immutable strings. So, let's start with the definition. A string is traditionally a sequence of characters, either as a literal constant or as some kind of variable. Most chances are that in the past you've probably worked with strings. Even if not in a computer science context, we write words, which are strings, or sentences, which are strings that contain white spaces, so you probably know what a string is. Now, a string can be a literal constant. For example, here, when we print the string hello, as you can see, this string is not stored in any variable in order to be used later or modified later or stuff like that. We just print hello. So what a computer does here is it stores the string in memory, but it does it only temporarily. After the print hello is executed, it is going to release that memory as we don't need this string anymore. And if, let's say, later we are going to print again another hello, it's going to build the hello again in another temporary memory segment and so on and so forth. Or a string could be stored in a variable. For example, here in this code in JavaScript, var s equals hello, or for example here in C++, there is even a type string, which is provided by the language, string s equals hello. A string is often implemented as an array data structure that stores a sequence of elements which are typically characters. For example, when we write this piece of code in JavaScript, var s equals hello, what happens is that the computer is going to find a contiguous segment of memory to store these characters, which will be of length 5 characters. So 5 times, I think 1 byte is a character, 5 bytes, it finds the segment, it splits it into 5 equal parts, and on each of them, it is going to store a character. This is how the word hello is stored into memory. As you can see, the characters are one after another, and they are 0 indexed. So this S looks exactly like an array, but be very careful, it is not an array. There is a difference between the data structure array and the data structure string. For example, in C++, as you can see here, S is declared as a string. We could also declare it as an array of characters, but we are going to see more about that later. Or for example, here in JavaScript, this is a variable, but when we initialize S with hello, the programming language is going to recognize that this is a string and S is going to be treated like a string. The most important thing that arrays and strings have in common is that we can randomly access elements by their index. For example, if I have this string, if I want to print S of 1, it is going to print me the character E, or S of 4, it will print me the character 4. The same rule applies here as in the arrays. Make sure to never exceed the string's bounds. So you can do something like S of 5. That is definitely going to result in a runtime error, or S of -1 or stuff like that. So be very careful. Now, one thing that we can also do is modify the characters inside the string. But there is a catch here. You can modify the contents of the string only if the string is mutable. So in some programming languages such as Python and JavaScript, strings are immutable. In other programming languages, for example, C++ or Java, strings are mutable. But let's talk about mutable and immutable strings now. First of all, what is an immutable object? An immutable object is an object whose state cannot be modified after it is created. This in contrast to a mutable object, which can be modified after it is created. This is a technique used in object-oriented programming in order to improve the runtime efficiency. And some programming languages took this one step further and adopted this idea with their own data types. For example, in Python and JavaScript, along other data types, the strings are an immutable data type. In Java and C++, strings are mutable. As you've guessed, both of them have pros and cons. Immutable strings are indeed good for runtime efficiency, but are not so friendly for the programmer, which most often will want to change maybe a character in that string or swap two characters or other changes. So, you can modify a mutable string however you like. You can modify a character. For example, I can say S of 0 equals H. And now these strings will become hello, but not with a capital H anymore. Or you can insert a character. I can write s.insert 0e, so I will insert the character e after position 0. What is position 0? This is position 0. So after this H, I will insert another E. So my string is this one. Awesome. And I can remove a character. If let's say I do s.remove1, I will remove the character at position 1, which is E, and my string is HLLO. So if you are a C++ or Java programmer, this is definitely good news for you. I don't know exactly for Java, but for C++, I can tell you that the strings are implemented as dynamic arrays of characters. But you should be careful when modifying a mutable string at the time complexity of that operation. So, something like this, modifying a character. This is constant, right? We can randomly access and modify characters in constant time. This is good. But when you want to insert a character into a string, this depends. If you want to insert it on some, let's say, random position, for example, here in the middle of the string, don't expect for this call to take big O of 1 time complexity to execute, because it won't. This will be big O of n. There is only one scenario in which inserting a character is big O of 1, and that is when you push it to the end of the string, right? Because this is the time complexity of pushing an element to the end of a dynamic array. So big O of 1 per push. Per push. Awesome. And this is also true for removal. Again, if you want to remove an element, let's say from the middle of the string, you have to expect big O of n time complexity, where n, by the way, is the length of the string. But you can do a pop, which is going to be constant, right? So big O of 1 per pop. Awesome. And this is the power of mutable strings. But the question is, does this mean that for you guys that code in Python and JavaScript, you won't ever be able to change a string? You only work with constant strings? Well, the answer is yes. You won't be able to modify a string once you have created, but fortunately, there is a workaround here. You cannot modify an immutable string, but you can convert it to an array of characters, which is mutable in every programming language. For example, you can convert the string hello into the array HELLO. If you want to insert and remove elements from the array, make sure you convert it into a dynamic array. But this is what's going to happen most of the time in Python and JavaScript anyway. There we use 99% of the time dynamic arrays. And yeah, modify the array however you want. And if you really need to return a string or have a string afterwards, just convert the array after it was modified again into a string. And that's it. Now, how can you convert a string into an array of characters? Super simple. First of all, the most basic approach is to use a for loop in which you are going to iterate through each of these string's characters and just push it into your array, which is going to be initially empty. Or you can use a built-in function or a syntactic sugar. I'm sure there is one in Python and also in JavaScript. And that's it, guys. Just as a recap, strings are sequences of characters which are stored in memory just like an array is, using a contiguous segment of memory. You can always randomly access one character in a string, but make sure if you want to modify that string to be either mutable or have it converted into an array of characters which is mutable, modify the array, and then convert it back to a string. Okay guys, this was it. I hope you enjoyed it, and I'll see you on the next one. Bye.